So today, after getting some questions by email, I thought it would be good to just see some examples of logarithms. So I've already made a video with an introduction to the concept, and I had a few examples in the video too, but maybe in this one we'll just do examples. We'll just focus on how you think about logarithms. Okay? So I always think we need to start somewhere that we can keep going back to over and over again as we do problems. So if I'm going to do a bunch of problems, I want to take it back to this in order to explain to you how I'm doing it, okay? So first thing here is this question, like what does a logarithm mean? To understand anything, you have to know what it means, okay? Otherwise, you're just going through the motions. So in this statement here, I tell you what a logarithm means. So if we say log base 5 of 25 equals 2, what does that mean about those numbers? Well, it means that 25 is 5 to the second power. If you like patterns, if a pattern would make it easy for you to remember, then this is at least the way I explain it. What a logarithm means is this base number, if it were raised to that power right there, would give you this third number right here. See, and that's what I wrote over here. I say 5 raised to the second power is equal to 25. And that's true. So these mean the same thing. I like to give the example that I know that you've seen this kind of thing before. You might not have realized it, but it's like multiplication and division. If I say 100 divided by 50 is 2, what's another way of thinking about that? Or what could I say that means? It means that 100 is 2 times 50. So there's still the same kind of a circular relationship between the numbers, all right? 50 times 2 is 100. Sure, that's what the division means. That's how to express the division in terms of multiplication. Okay, now let's look at a follow-up to this first statement about what a logarithm means. Can you tell me which of these two logarithms would be a true statement? One of them is true and one of them is not true. Can you tell me which is which? Okay, this one kind of, I think, is if someone was learning this for the first time, they may think this one looks like it's correct and this one looks like it's wrong. Because the numbers 3, 2, and 6, they seem to go together. So that's why I think somebody would believe that that's the one that's correct and this is the one that's not. But remember, I said we'd take it back up to this, all right? This is the meaning. So what does this mean? It means 3 to the second power is equal to 6. So how are you going to think about that? Are you just going to stare at it with an empty mind? No, you're going to have a way to think about it or interpret it for yourself. And the way that you think about this and interpret it and give it some meaning for yourself is you say, this means that 3 to the second power is equal to 6. But is that true? Is 3 to the second power equal to 6? Is 3 times 3 equal to 6? Definitely not. Okay, so this is the one that's not true, even though it had the allure of being or seeming like it was true. Okay, now I guess if one of these was true and one of these was false, then we know this is the true one because this is the false one, all right? Okay, so that logarithm is not correct and this one's true, but let's go ahead and verify it. What does this mean? How do you think about log base 4 of 64 is equal to 3? That would mean that 64 is equal to 4 to the third power. And if you multiply 4 times 4 times 4, which is what 4 to the third power means, that is indeed 64. So then we're in good shape there. That's correct. Okay. This one is true because what it means is true. All right. Okay. So let's try now some assorted problems. Suppose so we'll take something like these where every logarithm has got to be equal to something, okay? Like log base 5 of 125, it's equal to something. Like, you know, there's a number over here that completes that statement. You know, if I give you an analogy, if I say, I don't know, 12 divided by 3, is 12 divided by 3, is that just out there? Or does it equal something? Can you tell me an answer? Can you say 12 divided by 3 is, and you tell me the answer? It's kind of like this. Yes, log base 5 of 125 is equal to something. And the way that we can figure that out is by going back to this. Remember I said I'd tell you this to establish the meaning of a logarithm, and then we go from there. Okay, we can come back to this to understand every problem. So I'd look at this way. Okay, so whatever this is equal to, 5 raised to that power is going to be 125. So it's like I'm asking 5 raised to what power is 125. Okay, and if I don't know that, then I can use a little bit of trial and error. Let's see, 5 to the first power is 5. 5 to the second power is 25. And 5 to the third power, sure enough, that's 125. So that will be our answer. Okay? All right, so remember this was blank to begin with. My question was, what is log base 5 of 125? Well, it turns out it's 3. And what's the reason for that? Well, 5 to the third power, just as a matter of fact, is 125. Now, some of these will look a little bit harder because of the way that the numbers look. Like 1 over 81, that's not like a nice round number like 125, or square root of 4, or 1 over root 7. Those might be a little bit harder, but we'll have to just remember some things about exponents, okay? So what is this one asking? It says 3 raised to what power is equal to 1 over 81, okay? And if I tried to go in the same direction, I think I might get a little bit lost. So let's see, 3 to what power is 1 over 81? Well, 3 to the first power is 3. Okay, that's not it. 3 to the second power is 9. 3 to the third power, 27. And then I get to 3 to the fourth power and I get 81. But I'm looking for 1 over 81. 3 to what power is 1 over 81? I got 81, but that's not 1 over 81. But it makes me think that I'm close. And then I remember about negative exponents. What is 3 to the negative 4 power? How do you understand a negative exponent? How do you interpret it? What does it mean? Well, here's the way we interpret a negative exponent. 3 to the minus 4 power means 1 over 3 to the positive 4 power. Oh, 3 to the fourth power is 81, right? Okay, so that would be 1 over 81. So there's our number right there. It's negative 4. 3 to what power is 1 over 81? It's negative 4, okay? All right, so I still did that one with just some basic arithmetic, but I had to know about how to understand a negative exponent also, okay? So let's try these two, both involving roots. Now, in a video earlier this semester, I talked about fractional exponents, okay? So, for example, I think I would have given it something like this. If I have a number n to the power a over b, and so that power is a fraction. Fractional exponents are understood in terms of roots like this. So the number n to the fraction power a over b is the b root of n to the a power, okay? So that bottom number is the root, and the top number is the power applied to that original number n, whatever it is. So I could look at the square root of 4 like this. That's the square root of 4 to the first power. So as an exponent, that's 4, and the power is the fraction 1 over 2. Okay, now that's just like quick little review right there. Okay? All right, so let's see then. What is this question asking us? It says 4 raised to what power will give you the square root of 4? 4 raised to what power will give you root 4? Well, I just pointed out to you that root 4 is the same thing as 4 to the 1/2 power. So the power you raise 4 to get root 4 is 1/2. Okay, so there's our answer. It's 1/2. Think about it. We can check any problem. 4 raised to the 1/2 power is equal to root 4. Because that's what the 1/2 power is. It's the square root of the number. Any number to the 1/2 power is the same thing as the square root of that number. Okay? All right, now what about this one? Now this one will combine these two problems. Okay? Because I could think of it like this. I could say 1 over root 7. Well, the root can be understood in terms of a power like this. So we just finished saying, well, so the square root of a number is that number raised to the 1/2 power. But then negative exponents just mean something gets moved from above the bar to below it, or below the bar to above it. So see the bar there? This is under the bar. If I were to move that on top, the exponent would become negative. It would change signs. Anytime we move a number with an exponent across that bar, either above it or below it, the exponent will change sign. It will become, say, from negative to positive, or from positive to negative. Anytime it moves, the exponent changes sign. So I think this is what I want. Because what are we looking for? 7 raised to what power is going to give you 1 over root 7? Well, 1 over root 7 is 7 to the minus 1/2 power. So that's the power you want. See? We found it this way. That's what that power needs to be, negative 1/2. Okay. So there were some assorted problems that use a little bit of everything that you might encounter when you first start calculating logarithms. What it comes down to be some sort of common thread throughout these is you have to understand exponents. You got to know what 5 to the 3rd power is. You got to know that's 5 times 5 times 5. You got to know about what a negative exponent means, what a fraction exponent means. Okay, because logarithms are essentially exponents. That's what it is. All right, so let's do one more example that deals a little bit with vocabulary. So here's my original example that I wrote down that I said I would base the video on. Log base 5 of 25 equals 2 means the same thing as 25 is 5 squared. So these mean the same thing. They're not really any different than each other. It's just two ways of saying the same thing. This is called the logarithmic form of the statement, and this is called the exponential form of the statement. And if we're going to understand math and eventually, depending on what your career path is, science and engineering, we'll need to understand both forms and think between them and convert from one to the other. So let's try these two examples. In each of these, the exponential form is given, and can you write the logarithmic form? So it's like I give you this, and you figure out how to write that. Now there's a connection between the numbers, right? This is the base. This is what you take the logarithm of, and that is the power, all right? And you can always check your answer once you write it down. So about this one, let's see. Maybe it would even take some trial and error for you. Let's see. So the logarithmic form, would this be right? Log base 2 of 49 is equal to 7. Did I do that right? If this is the exponential form, is that the logarithmic form? Well, let's check it. What's this mean? Well, all logarithms mean that if this base number is taken to that power, you'll get this number. Well, 2 to the 7th power is definitely not 49. Not true. It's not the logarithmic form of that. Okay? All right, but I wanted to be dramatic a little bit and say that, well, you know, if you're trying to do this, you might make a mistake, but look, I checked it and I realized it was not right. The numbers just don't work. Okay? So anyway, let's do this. Let's do this. How about log base 7 of 49 is 2. Is that the logarithmic form of this? That's going to work. What's this mean? How can you verify the meaning of this? How are you going to understand this? You're not just going to stare at this, are you? You have a way to understand it. 7 raised to the 2nd power is 49, which is what we started with. That's what we wanted. We wanted to convert this back to what we started with. So there's your logarithmic form. Okay, what about this one? That one looks a little bit different. See here it says the exponential form is given. See that word exponential? What's the root of that word? Exponent. There's an exponent. Do you see an exponent? I see a root. I don't see an exponent. But I remember I told you how roots are convertible to fractional exponents. Okay, so if I'm looking at the 4th root of 256 to the 1st power, what's the exponent? The 4th root of 256 to the 1st power, the exponent would be 1 over 4. Okay, so let's rewrite this. We'll say, okay, that's not really the way that we want to see it. So we'll do 256. The exponent is 1 over 4 and 4. Okay? All right, so there's the exponential form. The exponent is right there. Okay? All right. So anyway, is this now, maybe it will take some trial and error. I'm going to write it down. I want you to think about whether it's correct before I say it. Okay? So we'll do log base 256 of 4 is 1 over 4. Is that the logarithmic form of this exponential statement? Is it true? Well, all right. What does this mean? How do you understand these numbers? How do you think about this? You say this number, if raised to that power, would give you this number. If we do that, is that where we started? If we take 256 and raise to the 1/4 power, do we get 4? Well, yeah, that's what we started with. This is saying the same thing as what we started with. If you want to, and you want a little help from the calculator, as we use logarithms more and more, then we will probably use the calculator more and more as we go on. But like, if you're curious, is that really true? That one's kind of hard to think about in your head a little bit. So, whoops, let's try it out. 256, and I'm going to raise that to the 1/4 power. And I'm just going to verify that we get 4 when we do that. All right, so we get 4. So yes, it's true. But you know, whether I had checked that or not with my calculator, this means the same thing as that because of my starting point. I said this is the meaning of every logarithm. This is how you think about every single logarithm that you'll ever see, including this one. Okay, all right. So now that's a little bit of everything to start with. About the basics, at least in one video. I went over how do you calculate a logarithm by just knowing a little bit about exponents, whether the exponents are a whole number, a negative number, or a fraction, or a negative fraction, okay? And then the other thing is, can you convert between these two forms? Can you convert between exponential and logarithmic and vice versa if you have to?